Hi student, welcome to the class of data structure again. So in the previous class, I was explaining that we are using stack to do various operations in recursion. And while explaining a little bit of that, I actually used operator, like I use like operator one, OP1 plus OP2, something like this for to represent infix. Actually, it's not operator, it's operand. Sorry for that. These are operands. These are called operands. If you do x plus y, okay, x and y are operands. This is the operations we are doing. Okay, so this is the operator. This is operator, and whatever we perform using this operator is called operation. These are operands, and this is operator. Okay, so that was one misunderstanding there. Now let's start with the class. So first thing first, I need to explain the format of these things again. So if you check here, these kind of expressions are called infix expression. Okay, if you write like a plus b, where here we have a operator, and on the left and right side, the operator is a binary operator. It means it uses two inputs. Then these are called operands. If it is using two operands and it is performing like a plus b, if you write it like this is called infix. Okay, so a little bit of expression can be written like a plus b star c. Again, in postfix, it can be written like a b plus. Here, these two are operands and this is the operator. Okay, so this operation will be performed on these two operands. So operator will be written after the operands. In prefix, the operator will be written before the operand. So a plus b infix will be represented in prefix like plus ab. Pre means before, operator before operands. Post means after operands. The operator will be written after. Infix means in the middle of the operands. Okay, so generally to study the mathematics, we use infix operation to understand it better, but computer uses postfix evaluations. Okay, and we will see how stack can be used along the way. Before going into that, first we must know the precedence of operators. The precedence of operators. So generally in mathematics, in your questions, any examination you give, the precedence will be given there that if some expression is written like a plus b star c, it will be given that star have higher precedence. It means this operation will be performed first. Then the output if consider the output of b star c is x, then a plus x will be evaluated next, and this will be our output. Okay, the final output. So based on the precedence of the operators, actually these things are done based on the precedence of operators. What if we write it like a plus b plus c? Here the plus have same precedence. So which one to evaluate first? That is called associativity. Generally plus minus star divide are left associative. It means the left operator will be evaluated first. You will calculate a plus b first, then c. It doesn't really matter here, but in some operations it does matter. For example, if you write it like here, if you say that, okay, star and divide have equal associativity, equal precedence. Similarly, generally in mathematics, plus and minus also have equal precedence. Okay, so if somebody write 10 plus 9 minus 11. Okay, 10 plus 9 minus 11. Now this will be evaluated first because it is left associative. These operators plus and minus both are left associative. If they have equal precedence and these are left associative, this will be calculated first. It is 19 here, then minus 11, which is 8. Okay, this is how it is going to be calculated. Even if you calculate this first, it doesn't really matter in case of plus minus, but it matters in case of like multiplication and division. Okay, multiplication and division, it does matter. If you write like 10 star 2 divided by, for example, 4 here. Okay, so here it is basically, if you evaluate this first, it is 20 divided by 4, which is 5. If you evaluated this first, I think it will be the same, 10 multiplied by 2, but it may change in some cases. Okay, right now I cannot think of an example, but you should evaluate as per the precedence as well as associativity. If two operators have, or a single operator have equal precedence, for example, of this case, a plus b plus c, it will follow associativity. For example, in case of power, okay, I can try to explain in case of power. Power is generally written like this in data structures by this arrow, a power b. So it will be a to the power b. Okay, sorry. Okay, a to the power b. This will be written like this. Now, if you say that a to the power b to the power c to the power c, and generally it is right associative. Generally it is right associative. Okay, but it will be given in your question, right associative. So how would you calculate it? Right associative means this will be calculated first. Okay, so it will be a to the power b c like this. Okay, c. Then again this will be calculated like a to the power b to the power c. Okay, so this is how it is calculated. It is also does not matter if you evaluate it left or right first. It will be result to this same thing again. But again, associativity does matter. We will see some example also where actually you will see how to do the associativity as well as precedence. Okay, precedence means some operators have higher priority. You should calculate them first in the expression. Then you should go for the lower priority expression. For example, here if you check, let me erase the whole page here. Here if you check, if you do like 10 plus 2 star, sorry. Here if you do, for example, 3 plus 2 star 2. So if you follow it any order, and you calculate this first. So it is 5 star 2, which is 10. But if you follow the precedence, which is given that a star have higher priority or higher precedence, you should evaluate star first. Now you can change. You can see the change in result. It is 3 plus 4, which is 7, and this is the correct answer. 7 is the correct answer. You can try your calculator also. So 7 is the correct answer. Don't enter. Just write 3 plus 2 star 2. Okay. So 7 is the right answer. So this is how the precedence and priority matters in our evaluation. Now let's see, this is the introduction, what is infix, what is postfix, what is prefix. Now let's move on to our example here. Here you have to solve this expression. So this is an infix expression. You will be given an expression like this. It may be given in numbers, or maybe some variables are given. These are variables, right? These are variables. All of these are variables. Now you have to convert that into postfix or prefix. Postfix is the same as prefix, just follow the reverse order. We have to follow the reverse order we have to follow, right? And I will be doing the postfix, and prefix is just opposite of that. Okay, so in our case, one second, in our case, what happens here? We define that power have highest precedence. For example, say that it have highest precedence. The precedence works like this. Power is greater than divide or star is greater than plus or minus. Okay, and it is given that this is right associative. This is left associative. This is also left associative. Okay, so if you see multiple operator of these together, you will evaluate this one first. Okay, you will evaluate the left one first. Okay, let's see here. Then we will use the stack, which will make our life easier and mistake free. that we do not do any mistake in this very simple calculation. So see here, I will write the first operation that is going to be performed as per the precedence as well as power, precedence as well as associativity. Okay. So here, if you see, 1 second, guys. Yeah. You can see here that this operation will be performed first because it have higher precedence and there is no other power operation here. So this will be performed first. Okay. After that, if you follow left to right associativity, this operation will be performed next. Okay. Then this, see now, the divide and star are coming together. Like D divide A star, the result of this operation, For example, if this is X, then what to do? This is left associative. See, this is left associative. So the left operator will be performed first. Okay. So here, this operation will be performed third. Then whatever is the result of 1 and 3, will be evaluated on the next attempt. Or next operation will be this one, fourth operation. Now simply follow that we are left with plus and minus. And this is left associative. So left plus will be calculated. Whatever the result of these two will be calculated. After that, so this is the fifth operation will be performed. Now the sixth operation is this one. And this will be the seventh operation. And how many operations do we have? 1, 2, 3, 4, 5, 6, and 7. Okay. In this order, it will be done. And again, just check the order. Okay. So I am writing the expression as per the order. And I have told you what is postfix expression. The operation will be returned after the operands. So this is one operand, this is first operand, this is second operand. After that, we have one operand here. Suppose this is X and then A. And we want to do sum here. So we'll write A X plus. Okay. Like this. So let's try to convert in our expression. I have labeled the operands. I have labeled the operations order in which the operation will be performed. I have already labeled them. Okay. So let's try to follow and try to write them down. In postfix expression, one by one. So we will write the first operation is this F G power. Okay. Previously it will be written like F power G. Now this is infix. I have converted into postfix. This is postfix. Okay. This is postfix. Now let's perform our second operation, which is C star E. So how it will be written? C E star. It will be written like this. Okay. Our next operation is D divided by A. So it will be written like D A divide. D A divide. Our next operation is between this value and this value. Whatever is the result of these two, we'll perform star on top of it. So consider this X and Y, and we are doing star here. The postfix expression will be X, Y star. So now what is X? This value, and this is Y. So we will write X, Y star here. Okay, X, Y star here. Easy. After this operation, what is our next operation? What is fifth operation? This one, B plus C star E. So whatever is the value of C star E, we do B plus here, B plus C star E. Okay. Now what again, the sixth operation is this whole thing, like between this, we are left with one intermediate operation, which is yes. Okay. Yeah. So now we have performed these operations. This have a value. Okay. Let me write it together. D A divide. This will have a value. This will have a value. And we are negating it. We are doing this operation. Okay. So consider this as X, consider this as Y. And we are doing X minus Y, right? So where we will write the minus in postfix expression here. minus. Then we are doing minus H. So we'll do H minus here. So this is the ultimate post in some clearly, let me write BCE star plus BA divide FG power star minus H minus. We will also see how stack will evaluate it. Okay, if this is given to a stack, how stack compute its value. We'll see that also. But first, we will see how stack calculate its value, this value. Okay. First, let's see more examples. So in prefix, if we try to write the same thing, what is the order? Let me try to label the order here again. What is the order? First, this one. Okay, so let's convert it into prefix FG power. The second operation is this one, which is DA divide. Okay, then what is the third operation? This one, which is written like CE star. What is the next operation? This star. So X, Y star here. Okay. So we are doing prefix. We are writing the operator after it. Okay. So this is X, this is Y. This is X, this is Y. And there is a star between them. So we have to put the star before X and Y. Okay. And we have put it here. Then we have, what is the next operation? B plus C star E. So we have B here and plus here. So we are doing, this is X, this is Y. Okay, so we have X plus Y and we have put plus here. It will convert into plus XY. What is X? X is B here. Y is star CE. Star CE. Okay. The next operation is this minus operation, which is between, this is X here. This is Y here. Okay, I did a mistake. Okay, this is X here. This is Y here. Okay, star is the part of between these two, this one and this one. So we are going to evaluate this this minus. Minus will be done here, written here. Then after writing H, this minus will be evaluated, which is minus H here, minus here. Okay. So this is the prefix expression. This is the prefix expression. Minus minus plus B star C E star divide D A power F G H. Okay. This is how prefix and postfix are written. So now you can convert any prefix or postfix into, any infix into prefix or postfix. Now let's see one more example of infix to postfix, where we are given with braces. Okay, braces. So braces have highest precedence. You can say that braces have highest precedence, and they are left associative. Okay, they are left associative. Braces are almost always, until unless it is given in the question that they are not left associative, always consider braces to be left associative. Okay, and braces have highest precedence. Now let's see how braces are evaluated. The first operation is this one, because this is the leftmost start and close brace. This is not the leftmost brace because there is no close to it. Okay, braces means pair of brace, with start and end first, So what you can do, you can check the end braces, the first end brace, and check it left brace. Check the next end brace, then check. So this pair is the first pair. This brace pair is the first pair. So this will be evaluated first. Then this is the brace start and end pair. This will be evaluated second. Okay. Then this will be evaluated 3. Okay. Then this will be evaluated 4, and then this one 5. So this is the precedence here. Now, if I have written that this is right associative, it means this operation will be evaluated at the 6th position. Then this operation, this operation, it means this whole thing. This is X here, this is Y here. So x power y, this will be evaluated at which position? 7th position. Then this power, right associative. It means rightmost power will be evaluated first. This one will be evaluated first, then this one, then this one, then this one. Okay. So this is the 8th operation. So how many operations do we have? 1, 2, 3, 4, 5, 6, 7, 8. This is the precedence of the operations. So if we try to convert it into postfix by removing the braces, let me go back if I can. Okay, let's try to convert it into postfix. I have removed the marking so that you can keep track without marking. Okay, let's start. We know that this is the first one. So the postfix will be AC minus. This is the second one. It will be, sorry, I am writing in prefix again. So it is AC minus BE divide. Then this is the third operation. So it is AC minus, sorry, this is AC minus BE divide, then star. Okay. Now this will be evaluated. So it is H, I should write after some space, HI plus, then this is the operation, J star. Okay. So this whole thing is done. Now this is the next position, G power. Okay. Then this is the next operation, which is, this is X here, this is Y here. Power we can write. Operands are already done. Then D and power. So this is the postfix expression of this infix. This is infix. Okay. Now let's see, let's try to use stack here. There are some rules to use stack. If you are using stack, stack is called what? Let me, yeah, it is called operator stack. Okay. So operands are coming up, but we are storing only operators in the stack, only operators, no operand in stack. Okay. Only operators will be stored in stack. So using stack means operator stack, operator, operations basically. And the rule is on the low priority, if there is some operator in stack already, we have gone through some of the infix expression. Okay, and we are in middle of some operation, and we are comparing that operation to top of the stack, because I already explained on stack we can do push or pop. That's it. On the top, that is why it's called last in first out, LIFO. LIFO. Remember that, LIFO. If you didn't understand stack, try to figure out how to use stack first. I explained in the previous lecture. Go there, try to do some example, then come here back, please. Okay, don't directly come here. You will not understand how stack is going to be used. You should know the basic understanding of stack. So on the top of stack, we have something, some operations like plus. Okay, now if star come up, okay, if star is coming up in the expression and we are comparing this star to the plus, star have high priority, we will push star here. Now, if this is the scenario, that's what the second statement is saying. Star is there and plus has come up. Then we will pull the star and print it, or you can say put it in the expression to convert it into postfix. What we are doing, infix to postfix, infix to postfix. Okay. If star is always there, which is of high priority, and low priority operator is coming up, then we pop and push this one. We will not only pop the topmost, we will pop until it is either the stack is empty or a low priority operand have come. Yeah. So basically, the crux of the matter is you are going through an infix expression. I will explain some examples also. And on the top of the stack, right now there is a low priority operator. So you push the current operator. Low priority or right associative operator. So for example, in case of power, if on stack there is a power already and the power is come up, the power operator is coming up, you push the power operator. Okay. And if this is not the case, the plus is there and plus is coming up. So this is left associative. So you pop the plus. You pop until the stack is empty or a low priority operator is coming up. You pop until then you push it. So let's see a expression evaluation A plus B star C. How this will be scanned. Okay, so I am using green color for the pointer. Now we are going from left to right. We are scanning the infix expression like this. Okay, so A is a operand. There is nothing in stack right now. Okay, let me use stack like this. There is nothing in stack right now, nothing, because this is operator stack. And for infix to postfix, we use operator stack only. Now plus, this is operator, push it. Now B, you write B because it is a, now the pointer is here. Okay. Pointer was on plus, so we push plus. There's nothing in the stack to compare with. Then B, then star. B is not a operator, so we print B. Then star come up. So once the star is coming up, plus have low priority. We are saying that plus have low priority compared to star. So in case of low priority, what do? We push it, and we print C. Once we have gone through all the expression, we pop and print. As we pop, as we print. Okay, so we pop star. So star will be printed here. We pop plus, so plus will be printed here. So this is the postfix expression. Okay, so let me go step by step again. I think I have gone through it very fast. Let me go step by step. So initially, the stack is empty. A has come up. We print A. Okay. Here I'm writing the expression, the whole expression. Right now the expression is A plus B star C. Now the expression is plus B star C. I'm reading the expression and I'm clearing the expression. Now the next is star plus. Okay. So you print what? You print A and nothing else. And you push plus here in the stack. So our expression is left with B star C. So what is next? Next is A and pointer is here on B. You will print B because B is a operand, not an operator. And this tag is operand operator stack. It can only contain operators. Okay. Now the expression is left with star C. Okay, we are on star. Star is the operator. So we will compare it with stack top. What is on top of the stack? It is plus. It is low priority compared to star. So we push star. What does our rule say? Rule say that on low priority stack top, if high is coming, high is star here, star is coming, stack top is plus. So we push it. Okay, so our expression will look like AB here and C here. We are left with C only. And you print ABC, all three. Now there is nothing left in the expression. There is nothing left in the expression. A, B, C. Now whatever is in stack, you will just spill it over and print it. As you pop star first. Star will come up. You popped it. Then you pop plus. Plus will be printed. So this is our postfix expression. Now let's do a more complicated one. In case of this one, yeah. First, let's do this left associative one. Here our stack will look like this. And our expression is A plus B minus C. First, you will print A. Our expression is B plus C minus C. Then plus has come up. There's nothing in the stack, so you push it. A again, there's only A. Then the expression is B minus C. Okay, the expression is B minus C. So you are on B. Okay, B is not a operator. B is an operand, so you print B. Now our expression is minus C, A, B. Now we are on minus. And it is left associative. And and plus and minus have same associativity. And these are left associative. Left associative means the left operator will be performed first. So minus is here. Minus is getting compared with plus. So what happens in that case? Plus will be popped. See your rule here. In case of left associativity, associative operators are coming up with same priority. We are popping. Okay. So we are going to pop plus here. Now stack is empty. Minus is here. So we push the minus here. And our expression is left with C only. A, B plus. So we print C. Now there is nothing in the expression. So we spill the whole stack like this. Here it is minus. This is our postfix expression. Now let's do one more, a complicated postfix expression. This one. It will clear all of your doubt. Okay. So we are here first. B will be printed here. This is our stack. Operator stack. Now we are on plus. There is nothing in stack, so we push it. Now we are here. So we print C. Now we are here. Star is coming and we are comparing star with plus. Star have high priority. We push star. It is given that this one have highest priority. Then these two have same priority. Then these two have same priority. It is given plus minus. And this is right associative. This is left associative. This is also left associative. Okay. So you push star. Now we are on E. E is a operand. We print it. Now minus has come up. Once minus has come up, what to do in that case? Minus has come up. What to do in that case? Minus is here. We pop until, because minus have low priority. See here, minus have low priority compared to star. We pop until it will find a low priority or right associativity, but minus is left associative. Okay, minus and plus are left associative. So we'll pop star first. We print it. Then we compare plus with the minus, and plus have same priority as minus, but these two are left associative. So we have to pop it also. We print. There's nothing in stack, so we push it here. Okay, we push minus here. Now we are on D. We print D. We are on divide. Divide have higher priority than minus. We push divide. Then star come up. Okay, and star have equal priority as divide. For multiplication have equal priority as divide, but these are left associative. So in case of left associative, we pop. So we pop this minus with this divide. Okay. Sorry, we print A first. We are on A first. In case of star, we are doing all sorts of things. So we pop this divide and print it here. Now what is in stack? Okay, so in case of divide, we have discarded it. What is in stack? Minus. Minus have low priority. So in case of low priority, we push star here. In case of low priority of the top of the stack compared to the current operator, we push it into stack. Okay, then we are on F, we print F, then power come up. So once the power is coming up here, we compare the power with the top of the stack. Power have high priority, so we push power here. Okay, we push power here, and we print G. We are on G. Then minus come up. In case of minus, what happens? Minus have low priority compared to power, star, and it is left associative to minus also. So all three operators will be printed. First power, then star, then minus. Then we push this minus here. Okay, then we print H. Now the expression have ended. There is nothing after H. So we spill everything. What is it in stack? Only minus. So we print minus. Now you compare this expression with my previous evaluation. This is using stack. Previously, we were using just our understanding. Okay. But computer have understanding only through stack only. Okay. So computer understand through stack only. So let's see our previous expression of the same question. It is BCE star plus BA divide FG power star minus H minus. Okay, you can compare it. BCE star plus BA divide FG power star minus H minus. So this is the postfix expression. How to evaluate how computer understand postfix expression, we will see. Why are we even doing the conversion? Because computer only understand postfix. We will see that part also. Okay. So now let's see our next example. And this is you understand, okay? This is that stack uses only operator stack. And it takes only order of n to convert infix to postfix. This is one of the application of stack. Okay, computer do it using stack. Okay, I just explained how computer do it. So let's see one more conversion, one more complicated conversion actually. One more complicated conversion where we have braces also. Okay, like this. B, same as the previous example. Start brace, end brace. A minus C star B divide E. Okay, G. So I told you that braces have highest priority and they are left associative. They are left associative. Okay. So this is the case. The rule with the braces is you pop the brace, you pop this brace. If you see this brace, only, okay. So this is the one of the rules with braces. Here, the rule with the brace is that we pop this brace only when this brace is come up. Okay. So once this brace come up, whenever the end brace come up, you pop everything till the start brace, till it finds start brace. Till it finds the start brace. That is the rule here. The rule, everything else is just the same. The only difference with the brace is that it should be balanced, right? If there is a starting brace, there should be an ending brace. Okay, and equal number of starting and ending brace should be there. So with braces, this is a valid braces. These are valid braces. These are not valid braces. See, right now there are only 2 ending braces, but there are 3 starting braces. Okay, and you can, using stack, you can validate also. Using stack, you can validate also, right? I'll tell you how. There are several interview questions of programming also that ask to find out whether braces are balanced or not. Okay, balanced means it should not happen like that. You have 3 ending braces, then you have 3 starting braces, or you have something like this and like this. Okay, now see here, these till here it is balanced. These 2 are not balanced. Okay, so how can you do it? How can you find out that this thing is not balanced? This thing is not balanced. Okay, use stack. Always push this brace, and whenever you find out the closing brace, this is the starting brace. Always push it. Whenever you see a closing brace, pull only or pop only the start brace. Okay, so let's start our pointer using red color. Our pointer is here only. So it is a starting brace. The statement is push starting braces, like this, and pop starting brace on this ending brace. Exactly one, right? Exactly one. And when it is invalidated, when there is nothing in stack to pop, or there is no starting brace to pop, just after this ending brace, when this ending brace is getting compared with the top, it should find a starting brace there. Okay, so our pointer is here. It is a starting brace. We push it. Now your pointer is here. It is a starting brace. We push it. Now ending brace come up. We pop. Ending brace come up. We pop. Now there is nothing in stack. Now again a ending brace come up. There should be a starting brace in stack. If there is no starting brace, we can say that this is invalid. Braces are not validated, not in balanced state. Balanced state or invalid. This expression is invalid using braces. Okay. So we are assuming that we have a valid expression. In case of this evaluation of infix to postfix using braces. Okay. What stack do? All the rules are same. It pull or it pop all the operators till the start braces. Whenever it sees a AND brace, it will pop all the operators till the start braces in stack, till it finds a start brace in stack. Then it pop the start brace also. Okay, now let's see how it happens. So using red arrow, I will try to point out on, okay, our stack will be very large here, very large stack, because there are many braces. Okay, now let's see what happens. This come up first. Our pointer is on. So this is a stack. I'm growing it like this. I'm growing it like this. Okay. If this line ends, I will start from here. Then I will start from here. So our pointer is here. We print D. Then power come up. We push power here. Okay. And in case of start braces, we do nothing until a AND brace come up. We push the start brace. Again, we have a start brace. We push the start brace. Then we have A, and it is an operand, and this is our operator stack. We cannot do anything, just push A here. Then minus come up, we do nothing. We push minus here. Then a AND brace come up. Whenever a AND brace come up, we pop and print until start brace. Okay, so a AND brace come up. We compare it with, okay, this is not a start brace. Pop it and print it. Now start brace has come up. Pop this also, but do not print because we are doing postfix evaluation. Now start come up. Start, find out that, okay, there is a start brace. There is a start brace. So do nothing. Then we are here. Then a start brace come up. So it will push the start brace. Okay. Then a divide come up. It push divide because just after divide we have a start brace. And these operators never touch start or end brace. Then we have E. It print, sorry, I forgot to print B. We print E. Then a AND brace come up. In case of AND brace, it compare the top of the stack. What is on the top of stack? Divide. So it print divide and pop it. Also it pop the start brace. It will stop after start brace only. Okay, after popping start brace, it will stop. Just like balancing, Okay. Now we have star on the top. Again, the pointer is here. End of the brace come up. Once the end of the brace come up, it will compare it with star. Okay, this is not a start of the braces. So it will pop, print it. Then it will compare with this. Okay, now start of the brace come up. It will pop here also. So what's left in the stack? Only this power operation. Okay. So the point here is, in case of braces evaluation, people can ask you, in case of braces evaluation, people can ask you that after this brace, what is the state of stack? What is there in the stack? They can ask you that after this brace, what is there in the stack? And the point here is it will be evaluated just like previous expression like this. Okay, just like previous expression like this. It will be converted into postfix like this. But the thing is, in case of start and end brace, we are not going to touch anything. Okay, we are not going to touch anything. In case of AND brace, once the AND brace come up, it will pop all the operators until it find a start of the brace. Okay. Now let's continue our question. Here we are here only. Okay. Now if you see, this power is a right operator. On top of stack we have power, so we push power here. Okay, suppose this is the power. We push power here. Then G come up, we print G. Then power, again power is the right operator, and on the top of stack we have power, so we push power here. The start of the bases come up, we push it. Start of the base come up, we push it. Okay. Then we have H, we print H. Then plus come up, plus see that on the top of the stack we have start of the base. So do nothing, just push it. What I told you that braces have highest priority. So whichever operator come up, it doesn't touch the brace because it have highest priority. In case of higher priority, in case of braces, even braces have higher priority. We don't pop it. Generally, in case of high priority, we pop it, but in case of braces, we don't pop it. Now this brace come up, so it will pop until it find a end of a start of brace. Okay, so a pop plus, print plus. Sorry, I forgot to print I. I will print it. It pop plus, so we print plus. Then it pop this start of the brace, and it stops because this end of the braces have found out its start of the brace. Then star come up. Top is here and star is there, so we push star. Then J come up. We print J. Then end of the brace comes. Now we pop until we find the start of the brace. Okay, so we pop star, print here. We pop start of the brace. That's it. Now there's nothing after this end of brace. So we pop and print. So we pop this one, we print here. We pop this one, we print here. Pop this one, this is we print here. This is the postfix expression. Now let's compare it with our expression. Yeah, this is the expression. It is the same expression. Okay. Now let's see some things also. Postfix evaluation. In postfix evaluation, we use what? Expression evaluation. We first convert it into postfix. If it is in infix, we convert it into postfix. Okay. And here we use operand stack. We don't use operator stack. So whenever an operator come up in postfix expression, we pop two operands from the stack top and do the operation, and again push the result. Okay, let's do it on this expression. Okay, so let's evaluate the result. First, let's convert it into postfix expression. Okay, how it can be converted? Using stack. So let's use stack here. First, the pointer is here. 8 will be printed, and then 4 will be printed. In stack, we have plus. Then our pointer is here. Then pointer is here. High priority operator is coming up. We push it. Then again, power is come up, but power is right associative. We push, so we push it. Then we have a divide. In case of divide, we pop until we find equivalent priority right associative. So divide is left associative anyway. And these powers are high priority. So we pop this one and pop this one and print it. Power. And we push divide here. Okay, so we print power, then we print 2. We are on 2, then star come up. Now you know that one star is there, and we are comparing it with top of stack, which is divide here, and this is left associative. So we have to pop it, and we push the star because top of the stack was plus, and plus is low priority compared to star. Then we print 5. Then minus come up. Now minus is low priority compared to star, so we pop, and we print star here, and minus is also left associative, so we pop plus also, pop plus, and we pop minus because there is nothing in the stack now, and we print 7. Now star come up, and star have high priority compared to minus, so we push it. Now 6 come up, 6 is there, divide and star have equal priority, but they are left associative, so we pop star, we print it, and divide have high priority compared to minus, so we push it. Okay, now pointer is on 3, we are on 3. Now plus come up, plus have low priority compared to this divide or minus. It is equal priority to minus, but it is left associative, so print, we divide and minus, and then we print 2, and we push plus here. Plus is the only thing that is left in the stack, so print plus. So our abstraction will look like 8, 4, 1, power, 2, divide 5, star plus 7, 6, star 3, divide minus 2 plus. Okay, this is our expression, postfix expression. Now to evaluate it, the rule is we are going to use operand stack. We push it until we find a operator. So right now the pointer is here on 8. We push it. 4, we push it. 1, we push it. Now we found out a operator, power operator. So what happens? It pops 2 topmost element. So this is our X, this is our Y, and do the operation, do the power operation, right? And again push the result into it. So it will do X power Y, which is X to the power Y, and push this result again back to the stack. So it pop 1 and 4. It will pop 1 and 4, right? It will pop 1 and 4. It will evaluate 4 to the power 1, which is 4, and push the 4 here. Now again power come up. So it pop 8 and 4, and it do 8 to the power 4 and push it here again. Okay, so I'm not going to evaluate it. 8 to the power 4. 8 to the power 4 will be pushed here. Now there is a operand, it push it here. Now divide come up. So this is our X, this is Y. It pop topmost 2 elements and do the operation, which is 8 to the power 4 divided by 2. Okay, so let me actually try to calculate 8 to the power 4. 64 multiplied by 64, which is 4096 divided by 2, which is 2048. So it is actually 2048. After doing this evaluation, we have 2048 in the stack. Now 5 come up, it push 5, it will push 5. Now star come up. Once the star come up, it topmost 2 element do the star operation. 2048 multiplied by 5 equal to 10240. So it is 10240. Right. Then 7, then it will do did I do some mistake here? Okay, I missed a 4 here. I missed a 4 here. Yeah. Here I missed a 4. So actually I missed this 4. This 4. So this will not how it is going to calculate it. Let's calculate it again. First 8 will come up, it will push 8. Then 4 will come up, it will push 4. Then 1 will come up, it will push 1. Then 4 will come up, it will push 4. Then power will come. So it will pop the 1 and 4. It will do 1 to the power 4, which is basically 4, which is basically 1. So it will pop these two and push the result of the operation, which is 1. Then again power come up, which is 4 to the power 1, which is 4. So it will pop 1 and 4, do the operation, and push it into stack. Then 2 will come up, it will push 2 into the stack. Then divide will come up, it will do the divide operation, which is 4 divided by 2, which is equal to 2. It will push 2 here. Okay. Then 5 will come up, it will push 5. So this is operand stack. So that is why we are pushing only operands in the stack. Then star will come up. Once the star comes, it will pop the topmost two operation, do the star, which is 5 multiplied by 2, which is 10. It will push 10 here. Okay. Then we do plus. So we do 10 plus, we pop 10 and 8, we do plus 10 plus 8, which is 18. It will push 18. Then 7, it will push 7, it will push 6. It will do star operation now. Okay. So now 7 multiplied by 6, which is 42. Okay, so it will push 42 here. Okay, then 3 come, it will push 3. Then divide. So 42 divided by 3 will be done. Divided by 3, which is 14. Okay. So 42 divided by 3, it will push 14. 42 divided by 3, 14, it will push 14. Now minus come, so it will do 18 minus 14, which is 4. It will push 4 here. Okay. Then 2 will come, it will push 2. Okay, sorry. I think I missed again something. Because there should be only one value left. Okay, yeah. There is only one value. It will push 2, then it will do plus. So 4 plus 2, 6. So 6 is the only element left in the stack after this evaluation, and 6 is the answer. Yeah, all right, guys. So I will do some more questions on those. Not on the evaluation, because I think it's done. Some more application of the like recursion. I will try to solve some like Fibonacci series power of using stack, and then we will close the stack and move on to the other these data structures. Thank you all for joining. Bye.